Today we're going to do a short lesson on solving exponential and log functions in the real world. We did already spend time solving exponential functions. We did that back in the beginning of the unit. I believe it was lesson 2. This is just a continuation of that, but this time we're going to include some logs in our word problems. So today we're doing one short example, and it focuses on the compounded continuously formula. The compounded continuously formula states that you have the final amount, and that's equal to the initial quantity. If it's in money, it's your starting point. If it's population, it is still your starting point. So the initial amount. This value of E is what we're going to use our calculator for. We have the rate, which will most likely be given to you as a percent, and you need to convert that to a decimal. And lastly, we have time. The time has to be consistent through the problem. So if you're dealing with years, then it's years all the way through the problem. If you're dealing with months, then it needs to be converted to months throughout the entire problem. So make sure you're careful with the time rate or the time value. So here we see a table that shows the number of hits a new website receives by the end of January and at the end of April in the same year. We see that in January, there's 125 hits, and in April, there's 2,000 hits. So we're just going to analyze this graph quickly, and what I do here is what you're going to be doing for all similar problems. If we look at the time, both of these values are given by the month, so we're going to say that time is in months. And more specifically, we're going to look at January being month 1 of the year and April being month 4 of the year. The time in between them, the time that we see between these two values is 3 months. So we're going to look at T, or we're going to use 3 for our value of T. 125 is the starting amount of hits, so that's your initial amount. That's going to be your P value. And 2,000, based on this chart, is the final amount. That's the final number that they grabbed for data. So 2,000 is your value of A, and that's the total. Or I should say final amount. So now we're going to look at the equation, just like we've looked at the compounded continuously equation before. We have A is equal to the initial amount times E raised to the power of rate times time. Now, the only thing we don't know in this equation is the value of the rate. We have no idea what R is. If we make a list off to the side of all our key values, we know that the final amount, the end, is 2,000 based on the data they gathered. We know that the initial amount, the P value, is 125, again, based on the data. And we know that T in months is 3. Again, the only thing we don't know is the R value. So we're going to solve for the R value. We're going to substitute in our A value of 2,000. This is equal to 125 multiplied by E raised to the power of R, which we do not know, multiplied by T, which is 3. And we're going to have to use what we know in order to solve for R. Using what we know is going to include using logs or natural logs. So the first thing that we're going to do is we're going to eliminate 125. To do that, we're going to divide both sides by 125. After we divide both sides by 125, we're left with 16 is equal to E raised to the power of R times 3, or 3R, which is how I'm going to write it. This goes back to the last lesson we learned where we're solving for logs and we don't have anything else to do, which is like a problem similar to this. So we could we started off by adding a log to both sides. Because we have e, we're going to add ln to both sides. So I'm going to write this as ln of 16 is equal to ln of e raised to the power of 3r. And just a side note before we go any further, ln is the same thing as log base e. Right here, if ln is the same as log base e, if we had log base e of e, that's equal to 1. We need to make sure we remember that. So I'm also going to write that off to the side. Log base e of e is equal to 1. That's one of the 4 properties we reviewed over the course of a couple of lessons. So these are just helpful notes that you need to know. Okay, so to come back to here and continue solving, I notice that I have an exponent. Whenever you have an exponent of a log, you can rewrite that in front. So I'm going to rewrite this as ln of 16 is equal to 3r times ln of e. And then at this point, I'm going to recognize that ln of e is the same thing as log base e of e, which is equal to 1. So now I have ln of 16 is equal to 3r times 1, or just 3r, of which I can divide both sides by 3. And that becomes a calculator problem. We can type in ln of 16 divided by 3. And our solution is approximately 0.92. If our solution is 0.92, it would be 92%. So 0.92 or 92%. Next, it says to write an exponential exponential equation to model the situation. So if we're modeling the situation, I'm not going to include the time for my model because the time could change. So I could ask you how many hits on the website after 5 months or after 9 months. So I'm going to leave t as a variable, but everything else I'm going to substitute into this function or into the equation. I guess actually, except for the answer, sorry. So when I say everything else, I'm talking about the initial value and the rate. So I'm going to write this as A because that's our answer depending on the months we're using. This is equal to 125, that's the original amount of hits, times e raised to the power of 0.92 times time. And again, I substituted in my initial value, obviously the e value stays the same, the rate, and the time stays as a variable, so we can change that. And actually that brings us to part C, which is where we're going to find our value of t. It says to use the model to predict the number of months it will take for the website to receive 2 million hits. All right, so if the website is going to receive 2 million hits, that means that's your answer, that's your final point. If I'm substituting into my equation, A is equal to 125 times e raised to the power of 0.92 times t, and I'm looking to find when it hits 2 million, I need to substitute 2 million in for A. 125 times e raised to the power of 0.92 times t. I'm looking to solve for t. So in order to solve for t, the first thing I'm going to do is eliminate 125. I'm dividing both sides by 125. That leaves me with 16,000 actually. 16,000 is equal to e raised to the power of 0.92 times t. Here's where we're going to use our ln, our natural log. We're going to add this to both sides. We have ln of 16,000 is equal to ln of e raised to the power of 0.92 times t. Property of logarithm tells us that if we have an exponent, we can rewrite it in front as a coefficient or a multiplier. So ln of 16,000 is equal to 0.92 times t times ln of e. And just like we reviewed above, up here, ln is the same thing as log base e of e. That means log base e of e is equal to 1, leaving us with ln of 16,000 is equal to 0.92 times t multiplied by 1, which I don't need to write. In order to solve for t, I'm going to divide both sides by 0.92. And in my calculator, I'm going to type in ln of 16,000 divided by 0.92, and I'm going to end up with an approximate value of 10.52. That means it's going to take between 10 and 11 months to reach 2 million hits. This is in months, so 10.52 looks like it's like directly in the middle of the 10th month. So I'm going to say it will take between 10 and 11 months to reach 2 million hits. You could just say 10.5 months, but I'm going to say between 10 and 11 months. All right, so as long as you remember your log properties from the previous lessons, then you should be fine solving these. This is the only type we're going to go over today, so you have one on your own problem, which you can check your answer on my website, and then you'll have one Go Formative question. Please let me know if you need any help.